Okay, everybody, we're gonna get started. So a couple of things to go through is I noticed a lot of you guys are having issues with the random number generation and making a lot of the same common mistakes. So I wanted to point out those mistakes to you here in this example. It's of course on the class Google Drive. And also, if you didn't realize it, everything that we do in class is up on that class Google Drive. All the examples are there and they get pretty much uploaded instantly as soon as I'm typing them. So make sure to check those out. So we'll show you a couple of different problems and then we'll also show you the right way of doing it. First way of doing a mistake, which is a new one that I haven't seen before, is what happens is every time you create a new set of curly brackets, you create a new scope for variables to live inside. So over here, someone was trying to do something where they set like the random number generator to the seed if it was given, otherwise to the time if it wasn't. But notice that we're creating new variables each and every time. I created a brand new variable. I created a brand new variable. But this variable only lasts for the duration of this function. Or not the duration of this function, the duration of that enclosing curly brackets. So I create a new variable who just happens to be named RNG, the exact same name as my variable outside. I initialize it to the argument, or the seed if it was given, and then I reach the end of the curly brackets and delete it. Didn't change the original. Same thing would happen here if I went to the else statement. I would create a brand new generator, again, who happens to have the same name as RNG, initialize it with the time, and then reach the end of my set of curly brackets and then delete it. So what's going to happen is by the time we get down here to line 71, it's still going to be this RNG because he's declared in the same set of curly brackets. So we'll always end up seeding our random number generator with 5. Even though we created two different ones that we seeded with different values. Does that make sense? So watch out for that. Some other common mistakes that I've seen. Here's an easy one. So these ones again are templated, and the whole point of this program is just makes vectors of random integers. So one common mistake to make is to have your AI only pick a single random number, right? And then consistently reuse that same random number every single time, right? So I might pick a random number, it might be 5, but my vector is just going to be filled with now 5s. Nothing else is going to happen, right? Because I'm not picking a different random number every single time. Another more subtle mistake is this one over here, where instead of passing a reference to the generator, I pass a copy to the generator. So inside it, I do get a different random number each time, but because I'm passing a copy to the function, I'm only modifying the state of the copy of the generator. So after the function completes, the generator that I passed in was unmodified, so it still has the same value. So if I call this function again, I'm going to get that exact same set of values back that I got the first time. Nothing's going to change here. Another mistake might be to, every time you call the function, reseed the generator with the seed that's passed in. That means it's going to set your generator to the beginning of its stream of random numbers, and so you'll end up getting the same sequence every time you call this function over here. So we'll get like maybe like 1, 2, 3, 1, 2, 3, 1, 2, 3, because we set the seed to be at the beginning of that stream of random numbers every single time. The other mistake that you could make would be to try to recreate the generator inside the function. Again, it's pretty much the exact same behavior as the prior one, except the generator is now inside this function. And the other thing is we create the generator and we seed it with the same seed. So again, we're going to get that same sequence of random values every single time. Do you guys have questions on any of these mistakes? Yeah. So yeah, you're welcome to use anything that we've done in class. And there's a ton of useful random stuff in the other examples that we've done before. So if we use that same seed, we should generate the same sequence of random values. So if it happens to be on a seed of 7, we get rock, paper, scissors, scissors, paper. If I seed you with 7, you should get rock, paper, scissors, scissors, paper as well in terms of what the AI generates. I should point out, though, that Macs tend to have a different implementation of min std rand, so you'll get a different set of values even if everything is perfectly correct on your machine and it's written correctly. Unix ones have had the same behavior, and the Cygwin has had the same behavior as what's on Codathon. But I'll also show you how to get your code up onto Codathon and run it there so you know what's happening. So finally, the right version, unless there are any more questions about the bad versions. So for the right version, you pass in a reference to the generator, right? So now I get the original. So every time I use the generator to pick a new random value, I'm going to be modifying that generator. And then the change will show up outside as well. The other important thing is over here in main, what you could do is you could default the seed to be the current time, right? But if the seed is specified, in this case, argv5 for my example, then I change my seed to be whatever it needs to be, whatever was given, and then I seed the random number generator with that variable. It will be the seed that was passed in if one was passed in, or the time if it wasn't passed in. And then when I call my good guy, right, I just pass in my random number generator over here. But because, again, it's a reference, he'll be modified every time. It'll get the original, and it'll be changing the original. So I'll get different values each time I call this function. Any questions? So right now, I'm having each one of them generate 10 values between 1 and 100, and the current seed I'm using is 17. If we go ahead and run this, you can see that in the good version, when we call it from good main, right, it generates a different sequence of random values every single time. If we only pick a single random value, right, it's going to be that same number repeated that many times because we didn't change each time. If we accidentally use a copy of the generator, notice that each set of vectors is identical because we didn't change the original. And so it'll be left at the same, it'll always start at the same state every single time. If we reseed the generator, we're going to get the same sequence of vectors every single time. And again, if we reseed the generator and recreate it, we'll get that exact same set of values. If you have the scoping issues, one of the problems here that you're going to find is, yes, we get different values, but these values are going to be with a seed of 5. So if I change my seed, which again you can do under the edit configurations, you'd hope if I change the seed I get a different sequence of random values. And if we look at the good version, it did get a different sequence of random numbers. But the bad version, the scoping issues, has that exact same value, and it's with a seed of 5. Any questions here? Yeah. Right here? Because I made that parameter optional, right? Because if it's not provided, I don't want to try to access the element index 4, right? Only if the seed is provided should I use it to set it, only should I use it. If I don't provide it, I'll end up going with the default, which is the current time. Any other questions? Okay. One other question that's kind of popped up a bit is, how do I make sure that I go left first versus going right when I'm doing the jump game? And really, like, what you have to do is make sure that when you do your recursion in your problem, you call the recursive call on the left before you call it on the right. And that will cause you to go left first before you go right first. You also want to keep the best option that you found so far. So if you find one that's equally good, you wouldn't replace it. So if you find an answer that's 5 long and you find another answer that's 5 long, you keep the old answer that's 5 long. So here's an example of doing checking if a list is sorted in Python. So if we have 0 or 1 elements, it has to be sorted. If there's 2 elements, if the first element comes before the second element, it's sorted. Otherwise, the list will be sorted if the first half is sorted and the second half is sorted. So what I do is I split my list into half. Here's the left half, here's the right half. And then I check first the left, check first the right, and this is just checking right here that the last element of the left is less than the first element of the right. But notice, the call to left came first. So I have to go left first before I go right. The only way it's going to happen. Or again, if I wanted to find the minimum of some list of numbers that same way, if I have exactly one number, that number is the minimum. Otherwise, I'll split my list in half like I did before, and then I'll get the minimum of the left, get the minimum of the right, and then find the smaller of those two. But notice I go left first before I go right first because I make my recursion call on the left half of the list, right? So for you, when you're doing your recursion, make sure that the index that you go to is the one to your left first before you call it on the one that's to the right. And that's how you go left over right. Does that make sense? Any questions here? Yeah. So like if you revisit the same place on the path, so you have to have a check in there like if I've already been here on this path, leave, right? Don't do the recursion. It's like literally you have to have something to check, right? So maybe you have your current answer and you have your current index. You're like, well, if the current index is in the current, or if the current index is in the current answer, return. Right? You left the function, you did nothing. And so it wouldn't modify anything. And you would just stop because you've been there before. Well, you return, so you left the function, right? So you go back to wherever your call, and then your guy will probably go like, oh, I went left, and if my left one was when I already been to, I'm going to go to the right. That's it. But it's literally that. It's like, have I been here before? If the answer is yes, just return. Anything else? Okay. One other thing with the random numbers is if the user enters in bad input on rock, paper, scissors, like let's say the AI chooses rock, right? And then the user enters in Bob as their play, the AI should not pick a new move. It should stay with its old move. So as long as the user keeps entering in bad input, the AI is not picking a different move. It's just staying as the rock, right? As soon as the AI, or as soon as the player finally enters in good input, right, we'll compare it against whatever the user entered. And then, you know, if it's a tie, we'll go again, and the AI will pick a different move, right? But you're only going to have like the AI is only going to pick one move per valid set of user inputs. Yeah. Or yeah, or you can make it so the AI chooses the move to make once you have the valid input. That works too. There is, but without using goto, yes, there is. You kind of have to have like an extra variable that says like get out forever, right? And if you set that equal to true, all of your for loops kind of check to see if you want to get out forever, and they would just break as soon as they found that variable was set to true. But there is no elegant, easy way to do it, unless like you want to leave the entire function and then you could return. But again, it leaves the whole function, not just the loop. Yeah. Again, there's a difference between like what the user enters and what you display on the screen. So notice that whenever the those new lines show up when the game is actually being played by a person, because they're pressing enter, and so their enter shows up on the screen, right? But if I'm only printing the program's output, I won't print the enter because that was part of the user's input. Okay, final thing might be like, well, how do I get my program up onto Codathon to test it if I just want to test it myself without actually using up my submissions? So what you do is you go over to Codathon, and I go back to the right class. And so you should see an option over here that looks a little bit different than mine that says copy to editor. If you've never pressed that button, press that button. If you've already pressed that button for that assignment, then you can just click over here in the cloud development environment. But I have to access it a little bit differently because I'm in like the instructor view. So after you either click on copy to editor or click on that little button over here, the cloud development environment, you should get something that looks like this sort of, right? It might look a little bit different, but more or less the same thing. So go into whatever assignment you're interested in doing, or you can just test any arbitrary piece of code. And so, for example, if I wanted to test like my rock, paper, scissors, for me, I'm going to go into submission, but you'd put whatever you want. I would say new upload, then go to add file, then go and find you're going to upload the .zip that you have previously. Spring 2019 programs. So like I have my submission, which again is just the zip that you would be submitting before. You click on that, say open, say upload. Then you would open up the editor or the command, the terminal over here, which you can do by clicking on the CDE apps and then clicking on CDE shell. It'll open up this guy. And then we need to go CD into that directory. So CD into rock, paper, scissors, CD into me, it's under submission. Then you'd make a new directory called build. So I'm going to remove my build just so you can see it. So I'll make a new directory called build, and then I'll CD into build. Now I need to run cmake, so I'll do cmake, and then you'll do -d cmake underscore build underscore type equals debug. Make sure that we're doing a debug build. If you leave off this line, it won't matter. And then ... because that specifies the directory that contains the cmake list that I want to compile, which is in this directory right here, the one right above me. So cmake will go ahead and run, and then you type make. And that will go ahead and build your project. After this is done, and this catches up, sometimes it takes a little bit of time. But I should have like a rock, paper, scissors in here somewhere. And then, maybe the seed of 3. And now my program is up and running and I can test it whatever way that I want. So I might say, hi or I or Y, and then enter in rock, and then we played rock. Does that make sense? So sure. So what I did is, if I go back up one level, right, I did make their build, right? This directory can be named whatever you want. And so that created my directory. Then I CD'd inside of build. Then I did cmake -d cmake underscore build underscore type equals debug. And then ... Again, that runs cmake to generate the configuration files, and then I do make to compile my program. And then after that, I will have my executable over here, rock, paper, scissors, which I can run by doing // rock, paper, scissors, and then again, any command line arguments that need to be given. So maybe 15 this time. Program is now up and running. And again, remember, this video will be up later tonight if you want to go back here and watch that again. So now you can test without submitting, right? And you can get the exact same behavior that you'll get when you actually do submit. You also do have access to all of my solutions, so you can keep messing with them and trying out things, but the onus of testing is on you. It's your responsibility to test, not mine. I just evaluate whether your code works. Having access to like my test cases, I think is like a big benefit for you, because you can see, oh, maybe I didn't think of something. But you should be racking your brain when you're testing things for everything that could possibly go wrong. If I say input is not going to be valid, try out lots of bad things in many different ways and forms and see if your program still works on that. So for some of you, this might be a little bit different than running your code on your own computers, because especially if you're running Mac, the random number generator is not the same on Mac as it is on Codathon. So over here, you'll get the exact same behavior. Some other things that you might want to do here is sometimes when you compile, you might get different warnings on different machines from different compilers. So maybe yours doesn't compile when you submit to Codathon, but it compiles on your machine because it's treating some different set of warnings on. You can find that here. You might also have undefined behavior in your program. So something might be happening differently in your program when you run it on your computer. It works fine, but you go and run it on Codathon and everything breaks. So again, you can get that same environment up here to help you figure out what those errors are. Now, one final thing I want to show you. Stop. Is you can run this command once for each project, sudo app-get update, sudo app-get install Valgrind. And what this will do is it'll update the installation stuff, and then it will download Valgrind. Valgrind is a very useful tool for finding undefined behavior in your program, which should be done in 1 second. This is generally things like going out of bounds on an array access. So if you guys are like still using the square brackets and you're like, oh man, it's not working when I submit it on Codathon, right? Try using .at instead, because .at will have the exact same behavior, whereas the square brackets will just always go to that index even if it's out of bounds. .at will be like, oh, you're out of bounds? Nope, I'm not going to do that, and it'll throw an exception. But sometimes you have other undefined behavior. So what you would do is after you get Valgrind installed, you say Valgrind --log-file equals some name. I'm going to call mine grind.txt. And then you do the name of your program plus any command line arguments. So here, I'm going to do rock, paper, scissors, maybe with a seed of 14. Then your program will start up, and you can say, well, maybe I want to do scissors. And yeah, I play rock, and maybe I want to play one more round. And then I say rock, and then I say paper, and then I say paper, and then I say scissors. And we finally end our game and we say, no, I don't want to keep playing. What this will do is, since I'm inside the build directory, it'll create a new file called grind.txt, which will give me like a summary. And if there are issues in here, you're going to get some complaints about it. Like this variable was uninitialized before use. Then you need to go figure out, well, why didn't my variable get initialized before I used it? Or you went out of bounds on an array access. There's some invalid read of some size after some allocated space. This will tell you where that out of bounds access happened to give you a better idea of where to investigate for those errors. Here, since my code doesn't have problems, we don't see anything interesting. Any questions about this? Okay, so use that, super duper helpful. And again, we'll probably see this popping up again later on in the class. So last time we left off, right, we were talking about how to build objects, and we were building a complex number. And so over here we went over constructors, right? These are the different ways that we can build our object. We can build it either from a real value and an imaginary value, from no values, from only a real value, or as a copy of another object. Remember that when you declare your function out of line, it has to have the name of the class in front of it. So complex number, : name of function, which the name of the constructor is the name of the function. And then there's our initializer list, where we have like colon, and then we say each one of our member variables, and then in parentheses, what we want to initialize it to. Quick review question for you is, when is your object fully created? So which line of code here would you say for the first constructor is our object, the complex number, actually created? Yeah. Not before the semicolon. Not before the curly brackets, but inside the curly brackets. So on line 8, my object is created, right? And all of its members have been initialized at this point, whether you said to do so or not. If you didn't say to initialize one explicitly, its default constructor was called. So over here, this is where you initialize your member variables. Here's where you need to do anything else to get set up, which could potentially involving initializing some member variables, but in a more complicated way. Remember, your object is created and all your members have been created and initialized by the time you get inside the curly brackets. here you can kind of think is after the colon and before the curly bracket is where I'm actually creating the members, or creating the space for the members and initializing those members to be some value. Any questions about the constructors? Okay. So the opposite of a constructor is a destructor. This destructor is the function that's going to be called when an instance of your class is destroyed. So this might be because you explicitly called delete on it, which we'll see later, or because it went out of scope. This function is what gets called to clean stuff up. In your destructor, you should clean up any resources that your object owns and is responsible for deleting. 99.999% of the time, it's going to be some dynamically allocated memory, which we haven't gotten to that. So your destructors at this moment are all going to be empty. They're not going to have any code inside of it. You might also put some other code inside of here that you just want to run when the object gets killed, for whatever reason. Objects on the stack, again, are going to be destroyed when they go out of scope. Objects on the heap, which we'll get to the heap in a little bit later on, probably in the next couple weeks, those are the things that you create with newer malloc, and they're destroyed when you call delete on them, or when you call free on them. Delete/free is called on them. If you don't need to do anything inside your destructor, you can just leave it empty. Compiler will provide one for you, but it's good to always create one. The way to do it would be like virtual tilde class name parentheses. So if we want to make a destructor for our class here, I would say tilde complex number. And again, we want to put the virtual keyword here. Now when I go to generate my destructor, I really don't have anything to do in here, but I'm just going to print out that I'm destroying the thing so you can see something going on in here. But again, for most of your guys' stuff right now, you're not going to have anything that needs to be done. So you might say sdt : cout, destroying complex number, real plus imaginary I. Yeah. No, so in C++, if you just say the name of a member variable, you'll just use it. You don't have to be explicit by saying like self dot like you do in Python. If you want to have that same kind of behavior or same kind of way of writing it, it would be like this arrow. But I'm like not a huge fan of typing, so I only do it when I have to. Some things to note about destructors is items in the class are destroyed in the reverse order they're declared and initialized in the class. So since we have real then imaginary, imaginary would be destroyed first and then real. Most of the time this doesn't matter, but sometimes it could potentially affect whether your program works or not. So if we had some class that had age, string, and nums, the objects would be destroyed nums first, then name, then age. So the backwards order. Member functions are like the things when classes start to get interesting, and those are the operations that you want to be able to perform on your class. A member function has access to all the class's member variables, as well as all the class's member methods, so you can call those as well. We'll talk about publicly available in 1 second. Inside of a class, if you want to call a member function, you just call it like any other. So you say function name. If the function is publicly available and you want to call it outside the class, it's an instance of that class dot member function. And then you pass in whatever args. One thing you're going to see here, which confuses a lot of people, is the uses of const. You can put const after the name of a function when you declare it. And if you put const there, that means that you're promising not to change anything about yourself. So I will not change any of my other member variables. Does that make sense? So if you're not planning on changing any of your members, put const after the end. And then we'll talk through protection levels and then do some examples. So when you declare a variable or declare a member of a class, it's going to be placed under some protection level. If you don't say a protection level, by default it will be private. There are 3 levels that you can specify. There's public, private, and protected. Public means that variable is accessible inside both the class and outside the class, or that member function is callable both inside the class and outside the class. Private means it's only accessible inside the class, right? You can't call it outside of the class. And protected is accessible by the class and any of its subclasses or children. We'll get to inheritance a little bit later. So right now, the only 2 that you're going to deal with are public and private. The way that you declare the protection level is just protection level : and then from that line of code on, everything will be under that protection level. And you can keep alternating. So you can say like public, some stuff, private, some stuff, public, some stuff, private, some stuff, if you wanted to. Generally, that's not how it's done, but it works. And it's perfectly fine. So again, the purpose of the protection levels is because sometimes you have implementation details. These would be the things that would be declared private that you don't want people outside the class to monkey with. And if you declare them as private, no one outside that class can mess with them. There's no way for them to touch it. This is sort of kind of equivalent to Python declaring one of your members as an underscore name. It's like underscore method or underscore variable. But in Python, you could still access those things even though you're not supposed to. In C++, if you try to access one of those things and you're not allowed to, the compiler is going to be like, no, and it won't compile. Public are the ways that you want people to be able to work with your code. And so when you're defining your functions, the first things that I would recommend doing is setting up like, what are your public member methods? How do you want people to operate with this class? What do you want them to be able to do? So if we go back to our set of code over here, right, I've set everything currently as public. I'm definitely going to need the constructors to be public, because if they're not public, right, no one outside the class can actually make an instance of my class. So your constructors are going to need to be public and your destructor as well. But my member variables, I might not want somebody directly messing with them. So I'm going to mark them as being private. No one can just directly access them. Now, the other thing that you want to think about is, well, what things do you want to be able to do with complex numbers? You want to be able to add them, right? So when you add two complex numbers together, you should get a new complex number. So we might have something like complex number, add, const, complex number reference. And I'm going to call this guy right-hand side, RHS, because it's going to be like ourselves plus the guy on the right-hand side. Now, because we're not planning on changing ourselves as well in the add, right? If you do A plus B, does either A change or B change? No, right? We're going to set this as being const, right? So now I can't change as well in this function. But again, you might want another version that's something like void add to self, which takes in a complex number on the right-hand side, and you basically want to do like the plus equals version, right? Like A plus equals B. You want to change ourselves, so we're not going to be const here. Does this make sense so far? Any questions? Yeah. We will get to the operator versions a little bit later on, but I don't want to do this right now. So over here, we might say generate a definition for add to self. So what do we do if we're adding two complex numbers? You're trying to add yourself, or add the complex number on the right-hand side to yourself. What should you do? You should add the real part. So how would I say that? Yeah, we'd say my real, right, plus equals RHS is, and if I want to access one of his member variables, I would say dot real, right? And then imaginary plus equals right-hand side dot imaginary, right? Nothing crazy or complicated going on. One thing you might be a little bit confused about is, well, how am I able to access the right-hand side's real member if it's private? Because again, it is private. But again, we're accessing it inside of this class, so it's fine. Right? So I have access to all of a complex's numbers member variables inside of any complex number function. So I have access to the right-hand side's private members because he's himself a complex number, and I'm inside a complex number function. Yeah. No, we're updating ourselves. So we'll show an example of this, and we'll also answer your question over here. So, right, I might have a complex number, num1, and it might be, 3 plus 5i, right? And then I might have a complex number, maybe like num2, and he's 10 plus 20i, right? So now I can do num1 dot add to self num2. So now I'm adding num2 to num1 and storing the result into num1. To answer the other question, if I attempt to do something like num1 dot real out here, since I'm not inside a complex number function, you can see the compiler's like, no, you can't do this. And if we hover over it, it'll say real is a private member of complex, which means you don't have access to it. If it was public, it would go back like, sure, fine. It's public, you can definitely touch it. Does that answer your question? Yeah. So it's a good way of thinking about it. So yes, num1, you always have access to yourself. So yes, it would be like a reference to num1 is what's being modified. But in terms of like actual arguments back here, num2 is right-hand side. Num1 is this object. So we're adding the right-hand side to this instance of the object. So this instance of the object will be updated. Yes, so the const back here is modifying yourself. I promise not to change, right? So inside this const function, I could not change real or imaginary of myself because I said I'm const. This const over here means I can't change the argument. Which one? The add? Yeah. So it's going to create a new complex number, right? So any thoughts about how we should write this function? So again, we're going to add like this ourselves, right, and right-hand side together, but we're not going to change this or the right-hand side. We're going to create a whole new complex number. Yeah. So we need to make a new complex number, and we should make a complex number that's a copy of who? Copy of this. But for, oops, why is this not working? Oh, there we go. But to say this is a pointer to this class. So since I actually want myself, I have to say star this. And we'll be talking about pointers, if not this week, then definitely next week. So it'd be star this right here. So I'm making a copy of myself. And then I could just do sum dot add to self right-hand side. And then I could return the sum. Yeah. Yes, in the first line of line 31, I'm calling the copy constructor. This guy back out here, so I just copy over the real parts and the imaginary part. Any other questions? So this is a pointer to yourself. Star this is really you. Okay. Let's say I wanted to write a function called negate that negated myself. What would that look like? What? Like make myself negative. So you have like a negative a, right? So negate yourself. So right, we want to negate, and we're not going to take in any arguments because we're changing ourselves. And we're not going to put const at the end because we're changing ourselves. So how would we negate ourselves? Or we would just do something like easy, like real equals negative real. Imaginary equals negative imaginary. Right? That should negate it. Right? And now maybe we want, in addition to be able to do subtraction, we want to be able to do something like void subtract from self. And we also want to be able to do the complex number subtract. So how might we do subtract from self, given that we already know how to add numbers? What's another way of writing a minus b? A plus negative b, right? So you might try to do something like this, like, oh, wait, I might try to negate right-hand side, right? That doesn't work. Because remember, negate changes, I shouldn't say this, I should say right-hand side dot negate. Right? This doesn't work because right-hand side is const, right? I can't change it. But negate would try to change it. So first we could make a copy, right? And then we could do negative RHS dot negate. So quick question. If we're calling this function back here, say main, and I do something like num1 dot subtract from self num2, when I call this function, who is this, num1 or num2? So again, when I call subtract from self, is num1 this or is num2 this? Num1 is this. That must mean right-hand side must be num2, right? Now, when I do this guy right here, negative RHS dot negate, right? We call this function, and when I make this function call, who is this? It's not num1 or num2. It's negative RHS is this at that point in time when I'm calling that function, because he's the guy that showed up on the left-hand side of the period, right? And then what I could do is something now I could do add to self. And again, if I don't specify an instance of the class, it's calling it on myself. So add to self negative RHS. Right? So I made a copy of the right-hand side, negated it, and then added the negated version to myself. Yes? So the question is there any benefit from passing a reference to passing a copy? Generally, it's better to pass a reference because you have to it saves time over doing the actual copy of the object. But you're going to be like, yeah, we actually just have to copy the thing, right? So here, it's probably a wash. So yeah, if we had just changed this to not be a reference and we had gotten rid of the const, then we could have just said, you know, RHS.negate, add to self negative RHS, and then we wouldn't have changed the original because we did have that copy. And then we'll also do subtract, which again, it's going to look really similar to the previous one. We'll make a complex number called difference, who is a copy of myself. And then we'll do something like difference dot subtract from self, right-hand side, and then we can return the difference. If any of you guys have ever programmed in Java, there's a method called toString, which returns a stringified version of that object, which we're going to write something like that right now. And because we're going to reference a string inside the header file, we need to include string. So I might have another public method called toString. And so we're going to return a string. String. We don't take any arguments. And will I be const or not const? Const, right? Because getting the string version of myself should not change myself. Also, like one thing to note is if you accidentally remove this const over here, this is a part of the type. This is a completely different function now. Because this function is a function that produces a toString that can modify yourself. Which was different than the one that we declared back in the header file because we said that one couldn't modify itself. So over here, what I'm going to do is I'm going to include StringStream, and I'm also going to include string. So what I might do is declare a StringStream called string version. This makes an empty string version, and so what I can do is fairly simple. I can write to this stream just like any other stream, but it will produce a string instead of like printing something to the screen or printing something to a file or reading something from a file. So I'm going to go to string version and write into it real. Maybe put a little space in here, plus imaginary I. And then if you want to get the string out from your StringStream, string version.stir will return the string version of it. So what we could do back here is like when I wanted to delete myself, I could just now call toString because we know how to print out strings. Any questions so far? Yeah. So what's going to happen is we're going to take real and we're going to convert it into its like, we'll take real and we'll write it to the string version. Then we'll write a plus sign to string version. Then we'll write the value of imaginary to the string version, and then we'll write I to it. Right? So we'll end up with real plus imaginary I, and then we'll print that out to the screen. Or then we'll get that string from that stream. The type of real and imaginary are both doubles. So now we might pop back over here, and we might say do something like std : cout num1 dot toString, and then we'll do the subtraction. Maybe we'll even do it twice so that we can actually see something. Or maybe what we can do is over here we do like num3. Num3 is going to be initialized to num1 dot subtract num2. So we build. Okay, there we go. So you can see over here that there was some like printing out here, because what I did is I made that number, then I copied it into num3, and then that copy is now gone, so it gets destroyed. So that's why you see that print statement happening here. But when we print out the first string, you can see, oh, it's 3 plus 5i. The next complex number is those added together, so 13 plus 25i. And the other one is their subtraction, so 3 minus 7 is -7, 5 minus 20 is -15. You can see the -15, and then we go and we delete them in reverse order. So we delete num3, then num2, then num1. So again, that's when the destructor is being called. That's what's making those print statements happen. You guys have any questions about classes so far? Yeah? Mm-hmm. Yes, there is the guards here also in the header file for the class. So the question is, would you need to include string back here in the .cpp over here? There are no guards on the CPP files. There would be guards inside of all of these files as well. But the reason this one isn't technically needed, because remember, this does a copy and paste. So it would copy and paste the pound include for string in there, but I just like to do it for safety reasons. I will see you guys all tonight, and we'll continue working on this stuff.